Pre-calculus students, welcome to section 10.4 on hyperbolas, and this is part 2. So let's try another example. We have a given x squared minus 9y squared plus 36y minus 72 equals 0. This is the equation for a hyperbola, and they would like us to find the center, the vertex, the foci, and the asymptotes, and to give it a sketch. So I have my handy dandy notes in my hand, right? And so I'm first going to put this equation into standard form for a hyperbola so that I know if it's horizontal or vertical, and then I can use all my information. So first of all, let's note that we have our x squareds that are positive, followed by our y squareds, which have a negative on them. And so I am going to go ahead and start with my x squareds, minus 9y squared plus 36y. And I am going to add a 72 to both sides. Again, I know the equation of a hyperbola has a constant on the right of the equation, which is a 1. So I will be working with that. Okay, so the first thing I need to do then is to do completing the square, because for equations for hyperbolas, as you know, the two parts, the x expression and the y expression, are perfect squares, perfect square binomials. Notice x squared already is perfect. I'm just going to write x squared as x minus 0 squared so that I can see that h. I am going to factor a negative 9 from both y terms because I know that the y's are in parentheses, right? That will leave a y squared. You have to be a little careful here. That will leave a minus 4y in parentheses. Notice if I multiply the negative 9 out to both terms, I get the same as above, right? The next thing I'm going to do then is make a perfect square trinomial for the y's, so I can write it as a perfect square binomial. I'm going to take half of b, which is negative 2, and square it. That is a positive 4, right? But notice I also have to add this amount that I've added on the left to the right-hand side of the equation. Notice that is not a plus 4. On the left-hand side of the equation, I've actually added a negative 36 that you see right there, negative 9 times 4. So I am going to add a negative 36 to the right-hand side of the equation. Okay, so I have x minus 0 squared minus 9. I know how to write my perfect square trinomial in its binomial squared form. That would be y minus 2 squared. Little math on the right. So now I'm going to divide everything by 36 because I need that 1 on the right-hand side. There we go. And we have x minus 0 squared. Notice that in the denominators for a hyperbola, they are values being squared. I am going to write 36 as 6 squared. Next, the 9 cancels and leaves a 4 in the denominator, which I'm going to write as 2 squared equals 1, right? So what I know is because my x squared term is first, I do know that this hyperbola is horizontal. And I am going to come on over here and fill in my variables. My h is a 0. My k is a 2. My a is a 6. My b is a 2. And to find my c, I have a formula I'm going to use at the bottom of my paper. That is b squared equals c squared minus a squared. No, I am going to fill in my b squared is 4. Right, my a squared is 36. I'm going to add a 36 to both sides. And I get 40 equals c squared. And when I take the square root, I get c equals the square root of 40. Or if I reduce it, it is 4 times 10 which would be the square root of 4 is 2 times the square root of 10. So I am going to write that value here. And now I have all the variables I need. I'm going to erase my work, first finding C. These are the variables I am using. I do see, again, the hyperbola is horizontal. So I am looking at the horizontal parabola at the top of my paper and using the variables that I have those values to fill in the information. The center is HK, which is 0, 2. The vertices are H plus or minus A, so 0 plus or minus 6, and my K. The foci are H plus or minus C and K. Here we go. The asymptote would be Y minus K equals plus or minus B over A, 2 over 6, which I'm going to write as 1/3 times X minus H, which is X. There we go. And there's the equation for the asymptotes. The last thing we're asked for is a sketch. So I'm going to erase my work here and put a sketch. Now, let's see what values I have. All right. I have 6s, so 1, 2. Here we go. Okay, so the first thing I'm going to do is my center is located at 0, 2. I'm just going to put a C there. My vertices, notice that, of course, they're horizontal from each other. We said this has a horizontal orientation at 6, 2 and negative 6, 2. Notice I put V's there to remind myself where my branches will start from. Okay. Now I'm going to get my B's in there on the conjugate axis. I have my transverse axis going. B is 2 away from the center. So up 2 and down 2. I now have the boundaries of my rectangle that will help me form my hyperbola. I'm going to make the diagonals. Oh, I went a little down there on the board. There we go. I'm going to make my diagonals. These are actually the asymptotes that we wrote. But it's so much easier just to draw the diagonals. And then now we're going to stretch our branches from the vertices to the diagonals. And there we go. We've done everything that they have asked from us. Hi, students, on to the next question. So we are asked for the standard form of a hyperbola with a center of 0, 0, vertices of plus or minus 1, 0, and asymptotes of y equals plus or minus 3x. So first of all, I need the orientation for my hyperbola. Notice it is horizontal because if I drew these two vertices, 1, 0 and negative 1, 0, then you would see that they are horizontal. And so I know the form that I need to write. I have my sheet in my hand, right? I am looking at the top. And let's write the standard form of that equation. There we go. If I fill in the H and the K and the A and the B, I'm all set. Let's take a look. So H and K are my center point, and I do see those are 0, 0. So that was nice and easy for me. Okay. For the vertices here, I am going to write underneath the equation for the vertices. That is h plus or minus a, and of course, here's my k. We already have that the k is 0, and so is the h, right? So I can see that my a must be 1, right? To make the plus or minus 1 in this position here. So my a is 1, right? Now, to find my b, all I have left to work with is the asymptote here, y equals plus or minus 3x. I'm going to write the equation for the asymptote underneath so I can compare. Y minus k equals plus or minus b over a times x minus h. Okay. Notice we already know that h and k are 0, right? So our left-hand side is a match. There we go, we have zeros there. Notice I also know that a is 1, right? So now when we compare, we can see that b must be 3 for the slope to be 3 over 1 there. And believe it or not, we are done writing our equation. Okay, now that we have worked with circles in the past and ellipses, parabolas, and hyperbolas, now when we have been given the general form of a conic section, it's important to be able to determine which conic section form it is. And so really we're just needing to look at the x squareds and the y squared. So let's go down the list. Of course, I have one of each. So notice for the first conic section, there is an x squared and a y squared. Notice they are both positive. So this is not a parabola. A parabola has either an x being squared or a y being squared, not both. Notice that they're both positive. So this is not a hyperbola because the signs would be opposite. So this is either a circle or an ellipse. And because the coefficients are the same on the x squared and the y squared, that would make a major and minor axis equal, making a circle. So this is a circle. Next, notice in this conic section, we have a y squared, but no x squared. That happens with any parabola. Next, 4x squared plus 25y squared. This is not a parabola because the x and the y are being squared. They both have the same sign as far as positive or negative. So it is not a hyperbola. This is either a circle or an ellipse. It is an ellipse because there are different coefficients on the squared terms, making a major and minor axis. This is an ellipse. Last must be a hyperbola, but that is easy to see. There is an x squared and a y squared, so it is not a parabola. The signs are opposite, so it must be a hyperbola. And that concludes section 10.4, and have a wonderful day.